because we are working with polynomial functions in this chapter, we are ready to look at long division of polynomials and then also the shortcut method of synthetic division. And actually, I put this wrong in the PowerPoint, it looks like. This is actually 2.3 in our books. 2.3. Okay, so first of all, let's take a look at how long division of polynomial works. So let's say we wanted to divide the polynomial x plus 2 into this cubic polynomial. Okay, so we treat it just like a long division problem, and we'll set it up this way, but instead of looking at what x plus 2 will go into it, actually what we do is we just concentrate on the first terms. So I look at the x, I want to know what do I have to multiply by x to get 3x cubed. Well, we'd have to multiply by a 3 and an x squared. So I put that on top. Then, just like in long division, we take that 3x squared and we multiply it by our divisor. Well, our divisor is x plus 2, so we have to distribute it through, multiply it by both. So 3x squared times x is 3x cubed. And then the 3x squared times the 2 is 6x squared. So after we multiply that out, then we subtract. So 3x cubed minus 3x cubed gives us 0. 8x squared minus 6x squared gives us 2x squared. Now we're just going to repeat that process again. So let's bring down the next term. And then remember, we're just looking at the x and the 2x squared here. So what do I have to take times x to get 2x squared? Well, we're missing the 2 and 1 factor of x, so that would be 2x. Now we're just taking this 2x and multiplying it by our divisor. So 2x times x is 2x squared, and then 2x times 2 is 4x, and then we subtract. 2x squared minus 2x squared is 0. 3x minus 4x is negative x. And we got to do it one more time. So we bring down the next term. Just take a look at the x and the negative x. What do I have to multiply by x to get negative x? A negative 1. So now, just like in the other one, I multiply just the negative 1 through to the divisor. So negative 1 times x and negative 1 times positive 2. And when I subtract those, everything cancels. So I have a remainder of 0. And what that means, if you have a remainder of 0, is that the quotient, this is our quotient, and the divisor are factors of the dividend. So if I would multiply x plus 2 times the quotient is what you get when you divide, so our quotient is 3x squared plus 2x minus 1. If I would multiply it by the divisor is the x plus 2. If I multiply these two together, it would equal our dividend here. Okay, so we've got a remainder of 0, so they are factors of each other. So that's long division. That's one way to do it. But you learned in Algebra 2 that there's a shortcut method of doing division, and that just eliminates all the x's. And what you do is you take, in this case, this is our dividend. So you want to make sure that it's in descending powers of the variable. So here we have our x cubed term, and then the x, and then the term without the x. But we're missing the quadratic term. We're missing the x squared term. So we have to put a placeholder of 0 in there. So our leading coefficient is 2. We're missing the x squared, so we have a coefficient of 0. The coefficient of the x term is 2, and then the constant term is negative 17. What we put on the shelf is the a value here. And so it's always divided by x minus a. So in this case, because it's x minus 2, we put positive 2 on this shelf. All right. We begin by bringing our leading coefficient down. Then we multiply the number on the shelf times that number. So 2 times 2 is 4. And here we add. So 0 plus 4 is 4. And then multiply again the number on the shelf times the 4. Add. Multiply 10 times the number on the shelf. And add again. So I get a 3. So we started off with the cubic, and we divided it by a linear polynomial. The linear polynomial was x minus 2. So that's 1 degree less than the other one. So what we end up with is the first 3 numbers here represent the quotient, and then this represents the remainder. All right, so we reduce the power by 1, so it is our quotient then. What we get after we divide is 2x squared plus 4x plus 10, and we have a remainder of 3. All right, so what that means then is the x minus 2 is not a factor. But if I would multiply the x minus 2 times the dividend, and the dividend was the 2x cubed plus 2x minus 17. These two are not factors because we have a remainder then. When we multiply those out, we would have to add on our remainder so that now this, all of this, when we do all of this, we will get back to that guy that we started off with, our dividend again. Okay? So synthetic division, if you get a remainder of 0, then they are factors. If it's not a remainder of 0, then you'd have to add on something to adjust it. So what you divided by then is not a factor. So the x minus 2 is not a factor here because we have a plus 3 at the end of it. Okay? So our remainder theorem tells us if a polynomial f of x is divided by x minus k, the remainder is f of k. All right, let's see if we can reason through this. So it says if a polynomial f of x. So let's take the polynomial where f of x is equal to 2x cubed plus 2x minus 17. Okay, and then we are going to divide it by, it says if you're dividing it by something of this form, x minus k, so let's go x minus 2, so that means our k is 2. It says the remainder is f of k. So this is k, so the remainder is f of k. Okay, well, let's see, what do they mean? F of 2. So if we have f of x is equal to this polynomial, f of 2 then, to figure out that value, we'd plug the 2 in for the all the x's. So we'd have 2 times 2 cubed plus 2 times 2 minus 17. Okay, 2 cubed is 8, times 2 is 16, 2 times 2 is 4, 16 plus 4 is 20, 20 minus 17 is 3. So f of 2 is equal to 3. Okay, so the remainder theorem then says if I take a polynomial and I divide it by an x minus k. Okay, so let's do that. Let's use synthetic. So, and this is the one we did before, but I'll just put it here again quickly. It was on that last slide. So 2, we don't have an x squared, so we put in a placeholder. And then a 2, and a negative 17. And because we're dividing by the x minus 2, we put a 2 on the shelf. So we drop down here. 2 times 2 is 4. Add, we get 4. 2 times 4 is 8. Add, we get 10. 2 times 10 is 20. Add to negative 17, and we get 3. So our polynomial was divided by this, and it says the remainder is equal to f of k, and our k was 2. And sure enough, those two are equal to each other. The factor theorem, though, says a polynomial has a factor x minus k, IFF, that means if and only if, f of k is equal to 0. All right, let's just take a quadratic. Let's say quadratic polynomial. So let's say we have f of x is equal to x squared plus 7x minus 8. Okay, I'll just pick something that is easy to factor here. So the factors are x plus 8 times x minus 1. So it has factors. So it says a polynomial, this is our polynomial f of x, has a factor of x minus k. So we can use either one of them. Let's take this one. That's said to be a factor if and only if f of k is 0. Okay, so if we're looking at this factor, the k is positive 1. So let's evaluate it, that function f of x, for 1. So f of 1, we plug the 1 in for the x's in the polynomial, so 1 squared plus 7 times 1 minus 8. 1 plus 7 is 8. 8 minus 8 is 0. So yes, indeed, x minus 1 is a factor because when we evaluate the polynomial for 1, we get 0. Now, it's also going to work for the other factor. Okay? So it says the x plus 8 is a factor if and only if f of k, and in this case our k would be negative 8, is equal to 0. Okay, well, let's evaluate it. Let's see what f of negative 8 is equal to. So we go back up to that original polynomial, 8 squared plus 7 times, or negative 8 squared, 7 times negative 8 minus 8. Negative 8 times negative 8 is positive 64. 7 times negative 8 is minus 56 minus 8. And sure enough, we get a 0. Okay? So these are considered factors. If when you plug in the k value, you get a 0 when you evaluate it for that k. All right? So that's the factor theorem. Now, the next one, it's going to ask us to factor, and we've got a cubic polynomial here. And so that means if we factor it, we are going to have, if it factors all the way down, we could have up to 3 factors. So that's the way we're going to get to an x to the third. It's like an x, and something else. So that's what we're looking for. It says to factor it, and we're given one factor. So we're given x plus 2 is one of them. We are looking for anything else. Okay? So what we're going to do is, first of all, divide it. Use synthetic division. It tells us it is a factor, so when we use synthetic division, then we should come up with a remainder of 0. So because x plus 2 is the factor, the negative 2 is the root, so we're going to put negative 2 on the shelf. Then we look at our polynomial that we're dividing into. Looks like all of the powers are there in decreasing order then. Our coefficients would be 1, negative 2, negative 13, and our constant is negative 10. Bring down the leading coefficient, negative 2 times 1, negative 2 plus negative 2, negative 2 times negative 4 is 8, negative 13 plus 8 is negative 5, negative 2 times negative 5 is 10, and when we add we get 0. So it is a factor. Okay, so right now we know that because we put negative 2 on the shelf, we know that x plus 2 is a factor, and the remaining factor, we want to go one less power than what we started off with. So 1x squared minus 4x minus 5. All right, so now we want to break this one down into the two sets of factors. So if you look at that, we want to factor this, we want factors of negative 5 whose sum is negative 4. So an x minus 5 and an x plus 1. If we multiply that out, we would get to this quadratic factor. So this is what we are looking for. Okay, so that's how you can factor with the synthetic division, you know, giving us some hints there, helping us divide it. And that saves a little bit of time. We didn't have to do a long division problem there anyway. Okay, now let's see if we know how to use the remainder theorem here. So it says evaluate f of x. We have a cubic polynomial for f of 3. All right, well, let's plug it in first of all and see what we come up with. So if I tell you our polynomial f of x is this right here, we're given this, and we want to find f of 3, that means we substitute in the 3 for the x. So we've got 3 cubed minus 3 times 3 squared minus 4 times 3 plus 15. Okay, so when we evaluate this, 3 to the third is 27. 3 squared is 9 times 3 is 27. Negative 4 times 3 is negative 12 plus 15. All right, the 27 and the negative 27 cancel. Negative 12 plus 15 is 3. So f of 3 is 3. Okay, the remainder theorem tells us, though, that we can also do synthetic division. We'll put the 3 on the shelf, bring down the coefficients and that constant term, and do the division, and our last number here should be is going to be our remainder, and we want to check to see if this last number, which represents our remainder, is equivalent to the f of 3 there. All right, so this is 1. 1 times 3 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. Negative 4 plus 0. 3 times negative 4. And we add, we get 3. Oh, that's an ugly 3, but it's 3. So yes, it does equal each other. So there's an example of the remainder theorem. All right. So very good, you guys. Hopefully you remembered all of that and doing that synthetic division from last year. And we will do some more of that work when we get back to class. Let's give him little cheeks this time. All right. See you soon.